Good afternoon, students, and Happy New Year to you.
Good afternoon, sir.
Good afternoon, sir. Same to you.
I understand that none of you had internet access over the Christmas. Is it true? Hello? Hello? Anybody hearing me?
Sir, you understand that what?
I understand that nobody had internet access over the Christmas holidays. Is that true?
Sir, did on and off.
Is it on and off? Was that so for everybody?
Yes, sir.
Yes, sir.
Sir.
No,
It never, it never come back. Go ahead. Somebody was saying something?
So I was saying that it's still on and off for me.
Oh. Benitez, I wonder through Christmas come and nobody not to put in the group. Happy Christmas, teacher. And New Year come and nobody not put nothing in the group. So I say, oh, that's the relationship that we share. So I say, all right, fine. So I say, let me be the bigger one to just come in and just say Happy New Year first. Not a good look. Really not a good look. But anyhow, there's no love lost. So we're hitting the road running today. I know the last thing that we did was when Matthew killed me. That's the only thing I could remember when I'm saying to myself, Lord, where did I reach? Where did I reach? And I couldn't remember. Can somebody remind me exactly what it is that we did the last time around?
I think it's Kramer's.
No, ma'am, we didn't finish Kramer's.
Sir, did
Sir,
the factorization.
Yes, sir. Factorization.
The fact and remain the theorem, don't.
Yes, sir.
Yes,
Yeah,
sir.
man. All right. That much I remember. All right. So question now. How many are you okay with the long division?
Yes, sir.
Yes, sir.
Yes, sir.
All right.
Yes, sir.
All right. There are one or two little things that I need to look at. Woo. All right. I'm going to give you something out of my head. I want you to listen carefully and I want you to write it. I'm going to give you 3 questions. And this is just for revision purposes. And then we'll pick up from where we left off. All right, so find the remainder using synthetic division, using synthetic, synthetic division, using synthetic division, really and truly, I talk about long division, eh? Using long division, evaluate the following. 3x cubed, 3x cubed, plus 5x squared, minus 2x plus 4, divided by x minus 1,
Sorry,
divided by x. Say it again.
Sorry, can you repeat, please?
I have no clue what I just said a while ago. I gave it out of my head, so I don't remember.
3x squared
No,
plus
cube.
5. 3x.
3x cube. 3x cube. It was cube.
3x cubed plus 5x squared minus 2x plus 4 divided by
X minus 1. Thank you. Now, number two. 7x cubed minus 5x plus 3 divided by x minus 2. Divided by x minus 2. And then the last one is going to be x cubed divided by x minus 2. X cubed, that's the only thing, x cubed divided by x minus 2. I'm going to give you about 10 minutes to work on those 3 questions for me, please. All right, start. Wait, nobody don't finish yet?
Yes, sir.
Yes, sir.
Yes, sir.
Oh, okay, no wonder. All right. Of course, I didn't start anything. I'm just sitting here because I don't remember the question. So can you tell me the first question, please?
3x cubed plus 5x squared minus 2x plus 4.
Minus 2x.
2x plus 4 divided by x minus 1.
All right. So I'm going to say x into 3x cubed goes 3x squared times. 3x squared times x is 3x cubed. And 3x squared times -1 is -3x squared. I'm subtracting. What is happening is that this becomes a positive sign. That becomes a negative sign. So what I'm now having is 2x squared. Take this down, I'm going to have -2x. X into 2x squared goes 2x times. Oh, come on. So this is plus plus 2x. 2x times x is 2x squared. And 2x times -1 is -2x. When I do this, it means that I'm dividing. I mean subtracting, I'm sorry. So that becomes a positive. So what now happens is that I'm taking down my -4, my +4. So I can say now 3x cubed plus 5x squared minus 2x plus 4 is going to be equivalent to x minus 1 times 3x squared plus 2x. All agreed? Is there anybody in the class that disagrees with me?
Sir, I
Yes.
agree.
I hear about
So
coming.
I'm gonna get the correct. I'm not really sure how I'm gonna get the sign them right.
Okay. So, all right, fair enough. So let us see if we can go through again because I'm hearing, oh, incidentally, it's a new year, 2022. I mean, I'll go through what I went through with you partially for last part of the first term, where I'm begging students to answer me. You're supposed to know me by now. You're supposed to understand what it is that I stand for. I reflected over the holidays while I was preparing notes for you guys. We've met for 8 weeks since the 25th of October to the 17th of December, 8 weeks. And I'm into my 4th unit. I need to now finish off this module so that I can move into the other module. Because by the time you look, it's May. You can say January finished, because once it started done, February, March, April, May, have 4 more months to complete 2 modules plus your IA. So I'm going to
Sir,
go through. Yes, honey.
sir, shouldn't that be 8x squared?
That's what I'm going to go through. I'm going to go. What should be 8x squared?
Yes, sir. That's why
Sir,
I
we
got
have the 2x squared.
we have the 2x squared.
2x squared. Yes.
Right here, so?
Right there. Yes, sir.
Right. So
Yes,
x into
sir.
that goes this times this is this times this is negative this times, and yes, you are indeed correcto. Let me close this here. I don't understand this thing. Hey, listen to me. School just started and we can't pretty sure. So this is supposed to be 8, and then I'm gonna have an 8 here, and 8 times that is going to give me an 8x squared. That means this is going to go so this is going to become 8, and that's minus 8, so that's going to become 7. That is going to be 7x plus 4, and this will give me a positive 7. 7x minus 7, and then this is going to become a positive
Sir, I think it's positive.
Sir, 6.
It's 6.
what is 6?
6.
Sir,
Not
7.
7x. It's 6x.
You know who don't ready to come back to work, right? Because negative 2x plus 8 is positive 6, don't?
Yes,
Yes,
sir.
sir.
Oh my Lord. You know what I was doing for the whole holiday then. This is 6, and it's supposed to be 6, and that's supposed to be 6x, and that's supposed to be negative 6, and that's supposed to be 10. That's what you got?
Yes, sir.
Yes, sir.
Oh my Lord Jesus, what is wrong with me today? I am not ready. Anyway, this is just me working a lot of math for the whole day. I was there preparing some stuff on trigonometry for you, which is the next area I want to move in. All right, so yeah, so this is what I would have gotten from the answer from the long division. Everybody all right?
Yes, sir.
Yes, sir.
All right, rope in the other one for me.
7x cubed minus 5x plus 3 divided by x minus 2.
Then, so where's the x squared term? I never gave you one?
No, sir.
No, sir.
No, sir.
The question can't work then. Can work?
Yes, sir, it can.
Yes, sir.
What you do? What you have to do?
Sir, I put 0x squared as a placeholder.
Excellent. 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 Have I done one like this with you before?
Yes, sir, in the questions that I gave us over here.
Right. I only gave it this to see if you guys remember. So that's very nice. So this is going to be 7x cubed plus 0x squared minus 5x plus 3. And then I'm going to say x into 7x squared goes 7x cubed goes 7x squared times 7x squared times x is 7x cubed. And 7x squared times negative 2 is going to be negative 14x squares. I'm changing this sign, that becomes a positive sign. So I'm going to have 14x squares minus 5x. And then this x into 14x squares goes 14x times. And 14x times x is 14x squares. And 14x times negative 2 is negative 28x. That becomes a positive because I'm subtracting. Of course, that becomes a negative, and this also becomes a negative. So those cancel out. So I'm going to have positive 23x. And then I'm taking down my 3. That goes 23 times, and 23 times x is going to be 23x. And 23 times 2 is going to be 46. So I get 49. Everybody agree with that?
Yes, sir.
Yes, sir.
So 7x cubed minus 5x plus 3 is going to be equivalent to x minus 2 times 7x squared plus 14x plus 23 plus 49. I'm hoping that the rest of you that I'm not hearing from, that I won't be calling upon today, will, yes, please.
So you said that you were going to explain the signs.
You're very low. Speak up again.
They say you're going to explain about the signs, how you get the signs.
What signs? What signs? Talk to me. What signs?
So find out the sign when you know when it's negative or positive.
We're talking about right here.
Yes, sir. Yes, sir.
No money. Remember, I'm subtracting, you know. Remember, every time I draw this line, I'm finding the remainder. Remember, I'm finding the remainder. I'm finding the remainder, so I have to subtract. So that's why the 7x becomes negative. And when I have minus 14x squared, it becomes positive 14x squares. And when I have this again, it means that I'm finding the remainder. So when I subtract, I'm going to get negative 14x squared minus 28x, it becomes a positive 28x. And here again, I'm finding the remainder. So when I subtract 23x from 23x, I get 0. And when I subtract negative from negative 46, I'm going to get a positive 46. And that's why I end up with a positive 49. So my remainder there is 49. So just remember that all that we're doing is subtracting. All that we're doing is subtracting. Nothing more, nothing more, nothing less. All we're doing is subtracting. Okay? Talk to me, please. Are you okay with it?
Yes, sir.
Yes, sir.
All right. There's a final one that I don't know if it can work out. Did anybody do it?
Yes, sir.
Yes, sir.
And got an answer?
Yes, sir.
Wow, this one was number 3. And what it says, something like x minus 2
X
into
cubed.
x cubed. Wow. Sir, why you give us something like that with only one term underneath it? Anyway, let us just see how far we can go here, sir. Oh, gollywog. Hold on, because this thing, as soon as it gives me the warning, it goes. So let me grab it very quickly. All right, great. So x into x squares, cube, goes x squares times. X squares times x is x cubed. But x squares times negative 2 is negative 2x squares. But sir, what am I going to add it to? Okay, I'm going to put a placeholder here for 0x squares. Then, sir, if you put one there, why never put one for x? And why never put one for the constant? Okay. So is that okay?
Yes, sir.
Yes, sir.
All right. Good, good. Now, for the person who answered the question just now, remember we are subtracting. Remember we are subtracting. So what happens when we are subtracting? That becomes negative, and that is a negative negative. So you're going to end up with a positive value. So you're going to end up with a positive value. So I'm going to end up with 2x squared. And if you want, I can carry my 0x. And then say x into 2x squared goes 2x times. And 2x times x is 2x squared. And 2x times negative 2 is negative 4x. Again, I'm subtracting. That becomes negative, that becomes positive. So I'm going to have positive 4x plus 0. And then x into 4x goes 4 times. And 4 times x is 4x. And 4 times negative 2 is negative 8. Again, I'm subtracting. That time becomes that. So I'm going to get my remainder to be equals to 8. So my answer is going to be x cubed is going to be equals to x minus 2 times x squared plus 2x plus 4 plus 8. All agreed?
Yes, sir.
Yes, sir.
All right, very good.
Sir,
Yes, please.
sir, you see, I have a problem. Sir, I got answers, right? But my layout is not like that because I've always had trouble with long division since primary school. So that's not how I lay it out. But sir, I have the answer.
Okay, Kimmy. All right, you have the answer. All right, so what I'm going to ask you to do is to see how best you can try and get the layout. See, not to say you get the answer, that's fine. But see if you can get the layout, because the truth is, they can ask you, they will ask you, they are going to ask you. And once the how sexy marks, your answer will give you sometimes just 1 mark. So the question carries 5 marks, and nothing in there so don't make no sense, but it's just an answer. It's just 1 mark you can get out of the 5, even though the answer is correct. So, so what I want to happen to you is that you get the layout from early on. I know you can read. You're a bright girl, so I know you can read. So I'm going to leave you to go and to do that for me, and I'm holding you accountable if after you try understand the layout and nothing don't work out, you need to link me and say, sir, I tried it, but now click.
Sir, I can link you too?
Sure, anybody can link me.
Because I not get it at all.
Natty,
Yes, sir.
Merry belated Christmas.
Sir, Happy New Year.
No, I don't want it to know. I don't want it not to be. I can't believe say you don't even reach out to your teacher and say, teach, log on. But anyhow, the point I'm making not to be, it's too early for you to say, no, I get it, you know. This
Sir,
was
but
from
you know,
last.
I did I get from the other time, sir, I never get it. It never lodge nowhere.
Yeah, but my friend, we get 2 weeks of Christmas. You need to know work over Christmas?
Sir, I'm not
All right.
getting no lie.
Okay, all right, fair enough. Me to do some work, you know, come to have to prepare some stuff for you, so me to do some work. I had to prepare. All right, hold on. I know I'm just trying to sort out my screen. All right. Life is not always black or white. Rockstone, our kid. Oh, come on. Yeah, life is not always black or white. We will sometimes have shades, and we need to deal with those shades when they arrive. So what kind of shades I talk about? Okay, so I need to reduce this by. All right, good. So sometimes we have shades that we have to deal with, and let me give you. Let me create a scenario, because I think that for now, you guys will understand the polynomial division for the most part. I know two people, Kimoli and Natty B, indicated just now that they're not fully getting it. I want to show you a method, another method, as we didn't look at that method before, and then give you an opportunity. Matter of fact, speaking of which, I think the last class before we went off, I had projected a few questions and asked you to picturize those, so you can have those to work on. Did anybody picturize it? Did anybody work on those?
Yes, sir.
Yes, sir.
Very nice. Very nice. Those yeses will turn into grade ones. The silence will have to be worked on in order to pass the course. And I can't just sit down. So, all right. So what I'm going to do is I'm coming back to you. So Kimoli, Natty B, I hear you. Allow me to just touch on another area. And when I touch on that area, I'm going to then I'm going to then go back to some of the division. I'm then going to go back to some of the division with you. All right, so so I am going to be talking to you now about the factor and remainder theorem. The factor and the remainder theorem. And then we can go back into looking at some of the examples and then doing, I want all of this to be on a page. Oh Lord, undo, 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 one more undo, right. And then now I'm gonna go back, I'm gonna go to be looking at the solution to this question, all right? So let us have a conversation. Factor and remainder theorem. Sometimes a question will say to you, find the remainder when this is divided by that. And sometimes them give you a 1 mark or 2 marks. No, if they only say to you, find the remainder and don't give you any instructions as to which of the methods to use, we're going to say use the remainder theorem. Use the remainder theorem. If they say to you, show that such and such is a factor of the polynomial, then use a factor theorem, right? Use a factor theorem so it is that you can show them instead of going through the long division. So what I'm saying to you is that if f of a is equal to 0, if f of a is equal to 0, it means then that anywhere in the function I see x, I would have put in a. F of a is suggesting anywhere in f of x, I see x, I'll put all of a. If all of that is equal to 0, then then x minus a is a factor of the polynomial. Sir, how you know that? Because I'm going to let this x minus a be equal to 0. And when this x minus a is equal to 0, I'm going to solve for the value of x, and it's going to be a. See it here, so? Right in here, so. So if f of a is equal to 0, then x minus a is going to be a factor of f, the polynomial. What I'm saying to you is, if when I get a remainder 0, I have a factor of the polynomial. I know one of the factors of the polynomial, if it is equal to 0. If you get any value other than 0, then you know that it's not a factor of the polynomial. Remember, when I started the topic, I was saying to you, when you got a remainder 0, don't say don't get anything. Anybody remember that?
Yes, sir.
Because I'm saying to you, 0 is very significant to this topic, because what 0 is telling us is that it becomes a factor of the polynomial. No, if f of b is not equal to 0, if f of b is not equal to 0, then x minus b leaves remainder r, and r is going to be a member of the set of reals. That's what this means. R is going to be a member of the set of reals when it divides f. So all the questions that we have done so far, it's not equal to, the remainder is not equal to 0. It means that this is not a factor of the polynomial. It's not a factor of the polynomial. So I'm going to say to you, use the remainder theorem to find the remainder when g of x is equal to all of that and is divided by that. Sir, why cross out factor? Because I am telling you to find the remainder. I'm saying use the remainder theorem to find the remainder. So I know it has a remainder right there, because the question says, so if it doesn't have if the remainder is equal to 0, then you're going to use the word factor. If the remainder is greater than 0, then you're going to use remainder. Am I making any sense?
Yes, sir.
So it said, somebody said no?
Yes, sir.
All right, so factor is equal to 0. Remainder, it is not equal to 0. So when we talk about the factor and the remainder theorem, if it is a factor of the polynomial, when you make your substitution into the polynomial, you're going to get your remainder to be equal to 0. If it has a remainder, when you substitute the value into the polynomial, you're going to get a value other than 0. So if it comes out to be 0, that's what you want. Because this topic not finished yet, because we have a little more something to do, which is why I'm taking a break from this so that Kimmy and Natalie can ease up them head a little bit before we start by the long division, because I'm going to go back to the long division because I need to show you something else. Watch me. So we're going to use the remainder theorem to find the remainder when g of x, which is equal to 3x cubed plus x squared minus x plus 1 is divided by x plus 1. So that means we're going to use a long division? No, because the question says to use the remainder theorem. Okay, so how that work out, sir? Okay, thanks for asking. Okay, so, oh, come on. It's too early in the semester to start to the foolishness. All right, that's 140. Let me reduce it because it's too early. All right. So this is what is going to happen now. So this is what is going to happen. So I'm going to let, well, not let, because it is already given. So g of x oh, father friend. So g of x hold on, please. Because that sly old fox swear say in the not you know foxy in swear say in the cause me to sin tonight. No, have that. All right, so I have a question here, so just trust me that this is what I'm giving you. So g of x is going to be equal to thought I had a question. G of x is going to be equal to 3x cubed plus x squares minus x plus 1. Now, they said to us, find the remainder when it is divided by x plus 1. When it is divided by x plus 1. So look at what sir is going to say. Divided by x plus 1, sir is going to let x plus 1 to equal to 0. Therefore, x is going to be equal to -1. That's the point I was making earlier when I said to you f of a is equal to 0. Therefore, x minus a is going to be the factor. So x plus 1 is what they told us to divide a polynomial by. And then now I'm going to find the value of x that will make that polynomial, that divisor, go to 0. So now I'm going to find g of -1. So why g of -1? Because remember, x is equal to -1 from right here. So I'm going to end up now with 3 times -1 cubed plus -1 squares minus a -1 plus 1. -1 cubed is -1. -1 squares is +1. And a negative number times a negative number is going to give me a positive number plus 1. So this works out to be -3 plus 1 plus 1 plus 1, which is equals to 0. What is your conclusion? What is a possible conclusion for this? What is a possible conclusion for this, guys? Talk to me. I just told you.
X plus 1 is a factor.
Very good. So you notice I crossed out something. So I can now say, therefore, x plus 1 is a is a factor of the polynomial g of x. So why you know that? Because when I substitute, when I use a factor theorem now and substitute the value into the function, I'm going to get my remainder equals to 0. So it tells me that I now have a factor of the polynomial. So I've used the theorem instead of going through and using the long division to get me that 0 there, yes, if I use the long division, I'm still going to get the same value. Now watch me. This long division is really for those who are not following, just to give them another opportunity to see what is happening. All right, but when they give you the question, they don't need to do the long division if they're using the remainder theorem or the factor theorem. All right, so this is just a proof. Let me call it. So I'm going to say x plus 1, Nati and Kimi, among others, 3x cubed plus x squared minus x plus 1. X into 3x cubed goes 3x squared times. 3x squared times x is 3x cubed. 3x squared times 1 is going to be 3x squared. When I draw that line, it means that I'm subtracting. So this is going to be 3x cubed minus 3x cubed, which is 0. And this is x squared minus 3x squared is going to be negative 2x squares. I'm taking down my negative x. And x into negative 2x squares goes negative 2x times. And negative 2x times x is negative 2x squares. And negative 2x times 1 is going to be negative 2x. Draw my line. I'm subtracting again. So it's going to be negative 2x squares minus a minus 2x squared becomes 2x, negative 2x squared plus 2x squared, which is 0. Watch me now. Negative x minus a negative 2x becomes negative x plus 2x, which only gives me x. And I'm bringing down this positive one right there. X into x goes 1 time. 1 times x is x, and 1 times 1 is 1. And of course, you can see x plus 1 minus x plus 1. So therefore, 3x cubed plus x squared minus x plus 1 is going to be equivalent to x plus 1 times 3x squared minus 2x plus 1. So I have proven to you that doing the calculations, whichever way you do it, you will still get your remainder. But you see how long that took me? Maybe about a minute and a half. But using the remainder theorem, factor theorem, I would have used about a half a minute to do the question. So it does save time. Then, sir, if I use the other method, would I be wrong? If the question says use a factor theorem and you use the other method, yes, you're not going to get in the mark. What did they say to you?
If them don't say if I can do it that way here, right?
Which is what I was about to say. If they don't tell you which one, if they're not specific, then you use the one that is you're most comfortable with. Fair enough?
Yes,
So
sir.
can you go back up, please? Thank you.
You're welcome.
Sir, so like how you write the long division answer, like for example, you have x squared equals bracket x minus 2, close bracket. You would write this answer? Just 0?
Me not put nothing there. See, me not put nothing there. Just this times this, me not put plus nothing because the remainder is 0.
Sir.
Yes, please.
Sir, 3x
plus the x squared. Why is it 2x squared? Should not be added.
Because this negative sign here multiplied by this negative sign here gives me a positive sign. So I'm going to have negative x plus 2x, which will give me a positive x. Talk to me now.
Yes, sir.
No, we don't like that. When they say yes, sir, what do you mean?
Sir, I understand.
Okay, good. Am I able to move?
Sir, one second.
Sir, is it always going to be is it always going to equal to 0? Where you have the let x plus 1 equals 0.
No, not always. Not always.
Sir, you can move
So,
on.
so how will you know?
How would I know? You have to work it out.
No, sir, not the answer. No, the part that you have let x plus 1 equals 0 to get the negative 1 is.
Right here, sir?
Yes, sir. Are you always going to put that?
Yeah. In order to know what it is, to know what to substitute in there. Yes, man. Yes. All right. So note here. I want you to note this and note this well. I said it, but I don't know how many of you will recognize. So note. So in this case, we would use the factor theorem. Everybody see that and agree why?
Yes, sir.
Yes, sir.
All right. So because your answer is, your remainder is 0, you'll know that is a factor theorem. Now, the question, how do I word the question? Well, you'll see how I do that. When I do the questions, you'll see how I do that. I don't know. All right, let us look at another one. I'm trying to find another. So use the remainder theorem to determine the remainder when f of x is equal to x cubed minus x squared minus 9x plus 1 is divided by x plus 5. I give you 2 minutes to do that for me, please. Quick and fast. Finish? Hello?
Yes, sir.
What's the answer?
Sir, I got negative 1/4.
Very good, Kimmy. Anybody else?
Negative 1/4.
Thank you, Tantan. Natty B.
Sir, I'm not finished.
All right, waiting on you. Hurry up. Good night, Patrine.
Yes, sir.
What's my answer?
Yeah, I'm not finished.
All right.
Sir, wrong.
Where you get?
Sir. What you say?
Come on, get no honey.
Sir, I get negative 54.
Negative 54. All right. Let's go. So Tanil, yes. So this is what, look at what turns you know, Tanil. I'm going to say let x plus 5 equals 0. So therefore, x is going to be equal to negative 5. And then in order to find the remainder, I'm going to say f of negative 5 is going to be equals to negative 5 cubed minus -5 squares minus 9 times -5 plus 1. -5 cubes is -125 minus -5 squares is 25. 45.
It's not supposed to be a positive 25
Why?
because it's two negative signs, sir.
Okay. Thanks for asking the question. But this will give me that 25, and this sign is this sign. And this -5 squares will give me this 25, and that sign is that sign. So no, it's going to be a -25. The sign that is left outside the blue bracket is the sign that I put back in front of the 25. And remember, -5 times -5 is a positive 25. So technically you have 3 negative signs there. Once you have an odd number of negative signs, your answer is going to be your answer is going to be negative. Tell me if you agree with me right there.
So I might have everything I have there. So.
Let me ask you. Agree with me that I've explained to you why the answer is a -25 and not a positive 25.
So I agree.
All right, bless you. Oh, so make your answer me so strong.
Come on, get it for 2 months.
All right, then let's go. So now this becomes that becomes -125 minus 25 is going to be -150, and 45 plus 1 is going to be plus 45 plus 1. So when I do that, I'm going to get -105 plus 1. When I add it, I'm going to get -104. And that's my answer.
Sir, I got that.
Very nice. Very nice, Tatiana. Nikki,
Yes, sir.
how you stay?
Let me get that.
Nice. Very nice. Shantipu,
Yes, sir.
how you stay?
Sir, when I did the long division, I got -54. And when I used the remainder theorem, I got -104.
All right, so you're going to fix that for me. You're going to fix that because you're supposed to get the same thing. So guess what? You just give yourself extra work, you know. All right, guess what? Towards the end of the semester, I did ask you guys what it is that I can do in order to improve the whole online experience. And I think somebody said, what did somebody say to me right in this class when I asked a question? Anybody remember?
No, sir.
All right. I think somebody said that, you know, if we could put in a little break in this stuff. I normally give you a screen break because I know some of you would have bio class from 3 to 5. That's why I start off 15 minutes later. So what I'm going to do, I'm going to give you a 5-minute screen break, but I'm also going to give you 5 minutes to do some questions that I'm going to be writing down. So technically, you're going to be having 10 minutes of me not interacting with you. But I'm going to give you 5 questions. So if you don't want the screen break, use that time to work on these questions that I'm now going to be writing. Of course, I want you to use the remainder theorem for these, and just get your practice. The quicker you finish, it's a more screen break you get. G of x is equals to, call that 5x cubed, 8x squared minus x plus 3 is divided by x plus 5. Too cute at all.
Sir,
Yes, please.
by x minus 5 by x plus 5.
X plus 5. I was just trying to fix it. Trouble? All right, do that. All right, so I'm still here, checking in on you. Have you completed all 5 questions?
Yeah, I'm at number 4.
All
At
right, then.
number 5.
Sorry,
All right. All right, I'll give you a few more. All right, just take your time. I'll give you a few more and then we continue. All right. You should all be finished by now. Hands down, should all be finished by now. All right, I got kicked out of one device and it's not letting me back in. What you got for the answer for the first one?
Sir, negative 417.
All right, so I'm not hearing you, Shanti. Shanti, can you speak again, please?
Sir, negative 417.
Is negative 417 okay with everybody?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Is there anyone in the class that did not get negative 413?
Yes, sir.
What you got?
Me, sir.
What you got?
So I got negative 423.
So I got like, what was the answer, sir?
Negative 417.
Almost frightened. So they said negative 413.
Mhm. All right, so I'll only do those that people didn't get. So f of negative 5 is going to be equals to 5 times negative 5 cubes plus 8 times negative 5 squares minus a negative 5 plus 3. This is going to be 5 times negative 125 plus 8 times 5 times 25 plus 5 plus 3 negative 675 625. 8 times that is going to be 200 plus 5 plus 3. That's 425 negative 425 plus 5 plus 3 is equals to negative 420 plus 3 is going to be equals to negative 417. Look at that
So
one,
you have,
Patty.
sorry, you have 402.
Oh, what is wrong with me tonight? Jesus, Father. And I bet it said 420.
You did though.
Oh my gosh. Thank you, hon. 420.
So why is it negative 625?
Because when you raise a negative number to an odd power, your answer remains negative.
Okay, sir, get it.
Mhm. Okay. Numero dos.
I see where I went wrong.
Fabulous. I was about to ask that afterwards, you know. Very nice. Numero dos. And especially that this was x plus a half as a factor. What's the answer?
Sir, repeat the question.
What's the answer for the second one? Nobody now get this right enough. I bet you any money.
Sir, I got negative 43 over 8.
You get negative what?
43 over 8.
Okay. Anybody else? Because what Kim only said to me don't make no sense a while ago. Negative 43 over 8. You can't have a number looking like that. No, sir. You can't have negative 3.
I got
What I get, sir.
Huh?
I got negative 7 over 8.
Negative 7 over 8. Kim only right. Big up yourself, Kim only. Kim only right. Kim only said negative 43 over 8, sir. That's my final answer, and that is it. So, did anybody write it as negative 5 and 3/8?
Yes, sir.
Yes, sir.
Nice. Same answer. Same answer. But I couldn't answer Kimoli the way I wanted to answer Kimoli because I don't want everybody to stop working. I wanted. Tani, what are you for the answer?
Negative 5 and 3 over 8.
Oh. No, you don't go on except now. All right, yeah, very good. So I guess I have to work this one. And I know why I gave you this one, you know why? Tell me why I gave you this one. Let me see if you're thinking.
Fraction.
Because hear me out now. I used most of my Christmas holiday to prepare my lesson on trigonometry. And I think I finished the lesson on trigonometry. I'm very excited now to teach it. And fraction is going to be the order of the day. I'm not scaring anybody, but you have to know your fraction. And your conversion, you have to know it. I forgot know your conversion, I forgot know your fraction, and them things there. And you have to know how to add 2 fractions out of your head quick and fast. You're not going to have time to put on calculator. Quick and fast. And you have to know them rules. And remember the rules, quick and fast. What to eat for breakfast? Egg and bread. What was for lunch? Patty and cocoa bread. What's for dinner? Sushi. Your man, you can't say, let me think. No, man. Quick and fast. Alrighty. So we need to evaluate number 2. Number two. All right, so we need to find k of negative a half, which is going to be negative a half cube minus 9 times negative a half squares minus 8 times negative a half minus 7. 2 cubes is 8, so it's going to become negative 1/8. 2 2s are 4, so it will become positive 1/4. So it's going to be 9 times 1/4. When I multiply 2 negative numbers, I get a positive number. Positive 8 times a half is going to be positive 4. And this is minus 7. And this works out to be negative 1/8 minus 9/4 plus 4 minus 7. All of this here, I'll have to, let me show you something quick and fast. If I multiply here by 2, and I multiply here by 2, I'm going to have the denominators to be the same. And I'm adding, and the denominators are the same. I'll just add my numerators and put back the denominator. So that denominator is going to be 8. 2 9s are 18. Minus 18 minus 1 is minus 19, 8. Everybody, what I just did a while ago?
Yes, sir.
Let me just repeat that. So I'm adding negative 1/8 to negative 9/4. Now I'm bringing, I'm finding the equivalent fraction to 9/8. So I'm bringing the denominators to be the same. Now, how do I carry the denominator to be the same? 1 is 8, 1 is 4. It doesn't always work as easy as this because some denominators are, very 2021. 2022 is when they look alike and easy to work, okay? So I'll multiply the denominator by 2. I also have to multiply the numerator by 2. When I multiply the denominator by 2, 2 times 4 is 8. So I have both denominators now the same. What to do with the denominator in a fraction, I have to do with the numerator so that I do not change the value of the fraction. It's just a scalar quantity that I'm using there, which does not make a difference to the question. And negative 9 times 2 is going to be negative 18. And negative 18 minus 1 is going to be negative 19. So I have negative 19/8 plus 4 minus 7, and plus 4 minus 7 is going to be equal to negative 3. Let me just get over here. So that is going to be equals to negative 19/8 minus 3 over 1. If I multiply this by 8, I'm going to also multiply that by 8. So what I'm going to end up with now is a denominator with a fraction between 8, 3 8s 24. So we're going to have negative 24 minus 19. So we're going to call it 20. So we're going to have negative 24 minus 20 is negative 54, negative 44. And that's going to be negative 43. So I'm going to get 3 times 8 is 24. 24 plus negative 24 minus 19 is going to be negative 43. And negative 43/8 is going to be the same thing as negative 5 3/8. You have to get with the fraction. You have to get with the fractions. You have to know how to work. You notice I don't find the LCM technically on paper right here. I just use my equivalent fractions to work with something. You have to get with the fraction. This is big school mathematics. Sir, but I don't understand why you do like that. You have to get with it. You have to practice and practice and practice. That's when you're going to get good at it. Take another minute and look at that for me, please. Before I question you on the third one. All right, so we're good?
Yes, sir.
Yes, sir.
What was the answer for number 3?
Sir, I got 17.
Oh, you get 17.
Sir, I got 4.
Sir, 4.
You get 4.
I got 4 as well.
That's not what I thought. Anybody else?
4, sir.
Yeah, that
4,
me
sir.
get. Yeah, that me get. You know, all the rest of them get 4. 4 me get. Very nice. Very, very nice. I'm very encouraged. So D of 3 is going to be equals to 6 times 3 raised to the 4th power plus 4 times 3 raised to the 3rd power minus 2 times 3 raised to the 2nd power plus 3 times 3 minus 4. 3 3 is
So it's
9.
because I put a placeholder, that's why I got the 17.
Oh, so cute. No problem. That's fine, huh? Sorry, which question are you doing?
So you're doing
Lord.
number 4.
Forgive me. I'm not erasing it, you know. I'm not erasing it. I'm going to do number 4 first. Forgive me. What's the answer for number 4?
Sir, you're 581.
581.
581.
Yes, sir, I got
581.
that too.
Everybody got 581?
Yes, sir.
Yes, sir.
Very good. Is there anybody in the class going once? Is there anybody in the class that did not get 581? Okay. So I'm going to erase it. I'm not doing that question. You know what? Thank you, Lord. Father God just said to me, say, you know what, my boy? Do the questionnaire because somebody in the class not understand and not say nothing. So for my sake, do the question. So I'm going to do it. 3 3 is 9, 9 and 81. 3 3 is 9, 9, 3 is 27. 3 3 is 9. Plus 3 times 3 minus 4. 6 8 is 48. 4 86. 4 7 is 28. 4 2 is 8 9 10. 2 9s are 18. 3 3 is 9 minus 4. 486 plus 108 is going to be 594 minus 18 plus 9 minus 4. 594 minus 18 is 576. 576 plus 9 minus 4. 576 plus 9 is going to be 585. 585 minus 4 is going to be equal to 581. And sure, I won't take any questions on that since nobody had an issue with that one. Let me just jump back to numero 3. Supposed to be h of negative 1 is going to be equal to 7 times negative 1 cubed plus negative 1 plus 12 is equal to 7 times negative 1 plus my negative 1 plus 12 is equal to negative 7 minus 1 plus 12, negative 8 plus 12, positive 4. Answer. All right. Looking good, looking good, looking good. Número 5. Número 5. Number 5.
Sir, I got negative 105 over 32.
Negative 105. No, that's not what I got for real though. Anybody else get another answer?
Sir, I got negative 8 and 13 over 64.
That make it. That make it. Anybody else got that? Negative 525 over 64 or negative 8 and 13 over 64?
Yes, sir.
Yes, sir.
3 students got it. Anybody else? Not good. What it is saying to me, students, is that there is an issue with your algorithm, your computational skills need improvement. And I'm going to tell you, once it has a fraction, it goes downhill. And that's what I'm sensing tonight. Once it has a fraction, it moves downhill. And the truth is, now we're able to get rid of the fractions. All the time for that matter. Sometimes you have to go work with the fractions. So we have to, must improve on this. We have to. All right. Let me give an attempt. Q of a quarter is going to be equals to a quarter cubes minus 3 times a quarter squares minus 12 times 1/4 minus 5. 4, 4, 16 times 3, 64. So this is 1/64 minus 3 times 4, 4, 16. That's 116 minus 12 times 1/4 minus 5. This is 1/64 minus 3/16. 12 times a quarter is going to be equals to 3 minus 3 minus 5.
So isn't it negative 1/64?
Oh, it's a negative x squared. Yeah. Thanks. It's a negative x squared. I was about to say no, it's a positive a quarter, but it was negative x cubed, not squared. Negative x cubed. Yes, you're correct. Thanks. All right. So if I 16 if I multiply this by 4, 16 times 4 is 64, don't it?
Yes, sir.
Yes, sir.
All right. So I'm going to multiply the numerator. Ouch. I'm going to multiply the numerator by 4 also. So I'm going to have this to be equals, this is over 64. 3 times 4 is 12, minus 12, minus 1 is minus 13 over that, minus 8 over 1. Multiply that by 64. Multiply this by 64. Rock stone. So this is going to be over 64. And what is 8 times 64? 64 times 8 is equal to 512. So minus 512 plus 13, that's 525. So I'm going to end up with negative 525 over 64, which gives me my negative 8 and 13 over 64. Some of you who offer are so silent. Go ahead and find an LCM here. Don't work the math like way teacher work it. I'm gonna go find the LCM. And those of you who you know yourself, you know one of the good things about it. When you sin, you know you have a conscience. But as humans, it becomes a part of us. So we do things over and over. And then we say, you know what, I will live with the repercussion. So for example, you're not supposed to eat chocolate because it triggers off your migraine headache. But you have a crave for chocolate. And you pass the chocolate factory and say, no, sir, I'm prepared to have a little headache. And you eat the chocolate, and when the head starts, you say, Jesus, do let me head not hurt me. But you know, so you're not supposed to eat the chocolate. What's the point, sir? You have a problem with fractions, and you know you have a problem with fractions, but you're not doing nothing to overcome that issue with fractions. And I'm saying to you, this is just the iceberg, you know, it's only 4 units we have covered out of 8 for module 1, you know. Only 4 units out of 8 we have covered from in module 1. The good thing about it is that it's the 4 hardest ones that we've covered already. And then trigonometry is going to be the last hardest one in it. And trust me, based on what I have done in my preparation, you should enjoy it. And then when I go through the first 3 areas, so I know, so although we don't look at unit 1 and unit 2 and unit 3. So we said, right. So we move to unit 4, then 5, then 6, then 7, then 8. All right. Unit 1, 2, 3 supposed to be an easy breeze over because those are easy. Easy breeze over. All right. So if you know where your shortfall is, don't let me have to tell you. Because we know. Whenever we sin, we know. So when you're understanding in class and you're not versus not understanding, you know. When certain something you're not understanding, also know. But what are you doing about it? Are you going to say, sir, I'm not following you? Or are you going to make it stay there and fester up, and then you lose the interest in the subject? Because math's too hard, I make it, I miss hurry my pay feet. But in truth and in fact, you were supposed to do something to overcome those challenges and you did nothing. Okay, very good. Very good for all of you who tried. Excellent for those of you who got all of them. Matter of fact, did anybody get all 5 of them correct?
Yes, sir.
Yes,
Very
sir.
nice. Very nice. Very nice. Is there anyone who got all 5 of them wrong? Let me see who's brave enough to answer. Okay. Anybody who got only 1 right? Okay. Anybody who got only 2 correct? 3.
Me, sir.
Yes,
Okay.
sir.
Not bad, nothing. Correct. Thanks for being honest. Thanks not to be for being honest. Anybody who got 4?
Yes, sir.
Very good, Tantan. Tantan, make a beating a Tantan. Tantan, which one? Oh, the one that you got the 17 something time that you made a mistake?
Yeah.
Oh, okay, all right, okay. I forgive you. I forgive you with that one. All right, very nice. All right. Okay. So I have introduced to you the whole business of the factored remainder theorem. The topic can be finished now, except that I have about half an hour left. And I want to give you another version of the question because I suspect that they can give you this on the paper. I suspect that they can give you this on the paper. What do you mean, sir? All right, let me show you. I am just going to get a little water break, but in the meantime, I'm getting my water break. So I want you to get a clean page for me. Get a clean page for me, and I want you to put this one down. Look at that question for me in the meantime. Just give me a few. I'll refresh myself a little.
Sir, what are we supposed to do?
All right, now. You see this question here? This question here, I'm going to ask you to solve. This question out of set here, solve. Out of set, solve. All right? Sir, but you never teach you how to solve them something. They said, sir, what's what the teachers them say now? Then teacher wants something in class, and then after that, not expect you to do something different. No, man, the teacher not say so. Let us go. This one here, we have to do something called trial and error. Trial and error. Let me just go back to your syllabus just to make sure that divide polynomials up to the third degree by linear expression, solve problems including the factor and remainder theorems. If x minus is equal to the polynomial, include finding the coefficients of polynomials when the remainder when the factorizing cubic polynomials where one factor can be formed by inspection. Okay, good. So this is the last part. So I'm actually at the last part of this business here. It says including finding coefficients of a polynomial given a factor or remainder when divided by a linear expression, factoring cubic polynomials where one factor. Okay, so factoring cubic polynomials where one factor can be formed by inspection. All right, so this is what is going to happen. I'm going to teach you a method that will take into that last part of the unit 5. So I'm actually wrapping this topic, the last part of the unit 5. And where are my notes? So it says, I'm going to teach you the trial and error method. It says by inspection. Sometimes when you teach by inspection, sometimes you're looking at it and you still not see where I go on, right? And I never like when my teacher said, solve something by inspection, no? Okay, if only I knew how to do it. It's all right. I will go through my method until I can develop the stuff. So let's go. Trial and error. This method works every time. Okay, thank you for responding, Tan. Trial and error. All right, so if you look at that polynomial, I'm using trial and error to find a factor of a polynomial because I have to do long division. I have to do long division to show to get my quotient, because my quotient is what I'm going to use to factorize in order for me to solve the question fully. So I have to do factor and I have to do my synthetic division, but also in order for me to go about this stuff, I will have to use trial and error, which really is my factor theorem, my factor and remainder theorem, because I'll have to perform both. And you recognize both of them are pretty much the same. When it becomes a factor, we call it the factor theorem. When you have a remainder, we call it the remainder theorem. All right? So I'm actually using both to find a factor of the polynomial. Then I'm going to divide the polynomial to show that I get 0, and then I'm going to solve with one extra step. So I'm actually compounding what it is that we have done. So I taught you how to do the synthetic division. Yes. This question also involves synthetic division, but this question also now is going to involve one step more to the synthetic division. So let's go. So if you look at the polynomial, you recognize that all the terms are positive. True or false?
True.
Yeah, man. So if I substitute another positive value inside here, you think I'm going to get 0? Hello, somebody? If I substitute another positive number in that, will I end up getting a 0?
No, sir.
No, I have to go substitute as some negative something inside here so that I can get my 0. So I can't put in any positive number. So what I'm going to do, I'm going to say let x be equals mute.
It look bushy. Come Google it. Give me.
No, Kuya. Miss Whitfield, you're supposed to be in a class. Miss Whitfield, you're supposed to be in my class.
It's going up too.
Tan, you are the host because I got kicked out. Can you mute her for me, please? Quick, before she starts talking other things. Tan, you mute her, please.
Oh my gosh. Sorry.
All right, Tan, you have to work closely with me here because when I got kicked out of the thing, you became the host. So you can just work with me, please. All right, so let's go. So I'm gonna let x be equal to -1. Sir, why not using a positive value? Because the 2x cubed, the 17x squared, the 14x, and the 36 are all positive numbers. And when I substitute a positive number into a positive number, positive expression, I'm going to get another positive value. That's not what I want. I want a 0. I want to find the factor of the polynomial. What is a polynomial, sir? The polynomial is p of x. Why is it called a polynomial, sir? It is called a polynomial because poly means many. It has many terms. So a question such as this is called, a function such as this is called a polynomial because of the many terms that it has. All right, so let's go. So we have done this before. So let us go again and do it. We just did this exercise not too long ago. So this is going to be p of -1 is equal to 2 times -1 cubed plus 17 times -1 squares plus 45 times -1 plus 36. Let us check to see that. That is going to be equal to 2 times -1 plus 17 times 1 minus 45 plus 36. Boy, this is going to be -2 plus 17 minus 45 plus 36. -2 minus 45. All right, -2 plus 17 will be 15. 15 minus 45. Boy, minus 45 plus 36. That might equal to 0, don't?
No, sir.
No. So I can't use that because that is not equal to 0. So I'm going to go now to my other number, which is going to be x equals -2. That's why it's called trial and error. That's why it's called trial and error. All right. So I'm going to go to x equals -2. So it's not equals to 0. So I'm going to go to let x be equal to -2. Mean the same thing. P of -2 anywhere into P of x I see x, I put -2 cubes plus 17 times -2 squares. Yes, Papa.
One teacher they tell me say when you do that for find the factors of the last number, you make it easier.
It doesn't always work. It
So
doesn't
random,
always.
just need to.
Yeah.
Sir, why
because-
-2?
I saw answer that one. Let me just go to Matthew. It doesn't always work because all right, Matthew, is 2 is also a factor of 36. True or false?
True, sir.
Yeah, but this -2 is not going to be one of the answers. It doesn't always work because 2 is a factor of the polynomial, and I can tell you because I wrote this question, I will tell you that 2 is not going to be one of the answers. So you have to be a little bit more purposeful in trying to find this one. Going back to the question now, why -2? Because when we're doing trial and error, we are trying to find the factors of the polynomial. And we never normally give students the question greater than 3. So if you try x equal 1 and it don't work, you try x equal -1. That don't work, you try x equal 2. That don't work, you try x equal -2. That don't work, you try x equal 3. That don't work, you try x equal -3. And by the time you reach -3, you must find the answer because we never normally give you more than that. So
Yes, sir, it's -3.
yeah, man, it has to be -3. Yeah. So thank you very much, Moni. So the point I'm making is math is a study of pattern. So we're not going to say plug in 40, then 36, then 29. No, we're doing it in sequence. We're doing it in sequence. So you try x equal 1, that don't work, x equal -1. Try x equal 2, that don't work. Try x equal -2. That don't work. Try x equal 3. That don't work. You try x equals -3. And I guarantee you by the time you reach -3, you would have found your factors. Other thing is, just miss me. You have to be very careful in performing these calculations. Really not difficult, and you get enough marks. So let me just show you, Matthew, that this one don't work. So this is 2 into -3. This is going to be -8 plus 17 times 4 plus 45 times 2 plus 36. That's -16. 7 4 is 28. That's 68 plus 90 plus 36. And we can look on that and say that's not equal to 0. So we're going to let know x to be equal to -3. Oh, I remember what I wanted to say to you now. Why am I only using negative numbers? I am only using negative numbers because when I look at the question, oh, come on. Sorry, my thing not responding. Hold on a minute, please. Well, for those of you who have the fraction in front, the polynomial in front of you, when I look at my polynomial is all positive. My polynomial is all positive. Oh, that's what I was trying to do. My polynomial here is all positive. It's all positive. So it don't make sense of putting another positive number because I'm not going to get it to be equal to 0. My aim is to find it equals, I'm getting it equals to 0 in order to find the factor of the polynomial. Remember, when you use the factor and remainder theorem, and you get your remainder to be equal to 0, what is it saying to you is that you have a factor of the polynomial. If it is not equal to 0, you don't have a factor of the polynomial. But in order to do this, in order to solve this polynomial, we need to find the factor of the polynomial first, and then use a factor to divide the polynomial. So let's go. We hear that?
Sir, so
yes, Papa.
3 can go in at 36, but they use 3 right there, so.
That's what I'm saying. 3 can go in, yeah, but I mean, somebody will say you try the factors of 36, but 2 is a factor of 36. 1 is also a factor of 36, So you try 1 to be a factor of 36 and it don't work. 2 is a factor of 36, you try it don't work. 3 is a factor of 36 and it works. So I'm saying to you, if you use that method that some other teacher told you, it's still tantamount to what it is that I'm teaching you, because you may very well use 1. Sometimes some of the questions, Matthew, the first one, they put in x equal -1 is a factor of the polynomial. The point I'm making is, somebody may say, but 2 is a factor of the polynomial. 2 is a factor of 36, sir, so I'm going to try 2. But we just did 2 and 2 never worked. But 3 is also a factor of the polynomial. 4 is a factor of, not the polynomial, 4 is a factor of 36. But will that work? So you can't just look at it at the last term to say you're going to be doing that. Mark you know that 5 won't work because 5 is not a factor of 36. So maybe that's the point the teacher was trying to make with you. But we're not going to go all the way up to 5. Never. All right. So let's go. So P of -3 is going to be equal to 2 times -3 cubes plus 17 times -3 squares plus 45 times -3 plus 36. 3 3 is 9, 9 3 is 27, that's -27 plus 17 times 3 3 is 9 plus 45 times -3 plus 36. Natty, you're too silent, That's -54. 76 is 3.
Silent.
You sorry, Natty, just answer me while ago. I just had a blank moment. 17 times 10 is how much?
153.
Right. And 45 times 3 is supposed to be 3 4 12 113, 135. So that's going to be -135. And then this is plus 36. Now let me check up this now. 6 and 3, 9, 5 and 4, 9 equals 0. So therefore, x plus 3 is a factor of the polynomial. Polynomial is a factor of the polynomial. Sir, how we always are putting -3, -3, -3, and then you just jump now, sir, to x plus 3. Excellent question.
Sir, because x plus 3 equals 0, don't it? And then
Very
x
good.
that equals minus 3.
Excellent. That's the response I would have given. Excellent. So we put in x equals minus 3. So that's why we get that x plus 3 is a factor. So what we're going to be doing here now, very good. So what we're going to be doing here now is to say x plus 3. But sir, 2x cubed plus 17x squared plus 45x plus 36. Then sir, if we get the factor of the polynomial, why we have to do the long division? Very good question, but let us do the long division first and then I answer that. X into 2x cubed goes 2x squared times 2x squared times x is 2x cubed. 2x squared times 3 is going to be 236x squares. Remember, I'm always subtracting, so I'm going to end up with 11x squares plus 45x. This goes 11x times. I have 11x squares here, and 11 times 3 is 33x. And I'm subtracting up there, and I'm going to have 2. I'm going to have 12 right there. Carry on my 36, and I have a 12 up here, and 12 times x is 12x, and 12 times 3 is 36. I put a minus sign there, and guess what? If I never believe myself that it was a factor of the polynomial, I just proved it that is a factor of the polynomial. Now, the final part of the question is that we now need to let 2x squared plus 11x plus 12 equals 0. And everybody see where that come from? That's the quotient. That's the quotient. Now we need to solve. Now we need to solve this. Now we need to solve this. Let me answer the question. Solve. All right. Yeah. So we need to solve this. All right. So what we're going to be doing now is to multiply the coefficient of x squared, which is 2, by the constant, which is 12. We'll multiply the coefficient of x squared, which is 2, by the constant, which is 12, and 12 times 2 is 24. So let us write down. We're prime factorizing. So how did we get the 24? Got the 24 by multiplying this 2 by this 12. All right? Positive 2 times positive 12 to give me positive 24. Positive 2 times positive 12 to give me positive 24. I'm prime factorizing. So 2 into 24 goes 12 times. 2 into 12 goes 6 times. 2 into 6 goes 3 times. And then the next prime number is going to be 3. So my prime numbers, my prime factors are 2 times 2 times 2 times 3, which will give me my 24. 2 times 2 is 4, 4 times 2 is 8, and 8 times 3 is 24. I need 2 numbers. When multiplied together will give me positive 24, but when added will give me 11. I need 2 numbers. When added together will give me 24. When multiplied together will give me 24, but when added will give me 11. Anybody see those numbers? What 2 numbers are talking about? 2 numbers when multiplied together will give me 24, but when added will give me absolutely 8 and 3. So look at how we would have gotten those. This times this is going to be 8, and then 8 times 3 is going to be equal to 24, and 8 plus 3 is going to be equal to 11. When I multiply, I get that, when I add, I get 11. So 8 and 3 would be the only 2 numbers that will fit this this question. So I'm going to have, and this is a recalling because you learn this from CXC. So what we're going to have is going to be 2x squares plus 8x plus 3x plus 12 is equal to 0. And you see, this now is now my 11x. And then I'm going to group to give me 2x squares in one bracket plus my 8x. I will always leave the middle sign out every single time. I'll always leave the middle sign out every single time. So I'm going to ask you the question, what is common here between 2x squares and 8x?
Two x.
Very good. So 2x is common, and then what is going to be left is going to be x. What is going to be left with 8x?
4.
4. What is common between 3x and 12?
3.
Good job. And what is left?
X plus 4.
All right. Now, the same something in the bracket here has to be the same something in this bracket here. And because those two same something in the brackets are the same, I'm going to say x minus 4, x plus 4, I'm factoring it out. And then what is going to be left is going to be 2x plus 3. And then, of course, I put that equals to 0. Now I would have factorized my 2x squared plus 11x plus 12. Now I would have factorized my 2x squared plus 11x plus 12. All right? Now, the question did say to solve. The question says solve. Right? If the question had said factorize, the question would have finished. Because my factors would have been x plus 3 times x plus 4 times 2x plus 3. But the question says to solve. So I'm going to let x plus 4 equals 0, which implies that x is equal to negative 4. And 2x plus 3 equals 0, which implies 2x is equal to negative 3, and then x is equal to negative 3 halves. So what I can say to you now is, if only I can remember my question. What I can say to you now is, sorry, my system is behaving as if it wants me to see. But here. So I'm going to have no as my final answer. Let me just write it since I don't want to bother go x is equal to negative 3. And we got that piece from up top long before. So we have our 3 sets of answers for the question. Our 3 sets of answers for the question. So any one of those, all 3 of those, and we substitute it into the original polynomial, we would get our polynomial equals to 0, because those are solutions to the polynomial. How do I know that I have 3 answers to this question and there are no more answers hiding? How do I know I have 3 questions? 3 answers. How do I know that I have 3 answers to this question? What is the order of the polynomial? What is the highest power that the polynomial is raised to? Three. Remember?
3.
Right. The highest power the polynomial is raised to is 3. Yeah, man, it's when you do them questions, you feel like a bright. 1 page and a half a question that you feel bright when you do a question like this. Oh, come on. All right, here you go. Sit here. The highest power in the polynomial is a 3. So it tells us that it has 3 answers. And this is what we call the order of the polynomial, the highest power. Right? So it tells us that we have 3 answers. So you know exactly how many answers you're supposed to be getting when you solve a question such as this. All right. Now, this is easy, man. The first night of class, you say the man is like easy for me. The man come to class and do a full class of blow. What a man. Guess what? Time is at hand. We have a lot to cover in a short period of time. and I have to make very good use of it. So sorry to disappoint any of you who think I thought I'd been a little bit easier on you tonight, but it is what it is. Are there any questions? Anybody learned anything today? You know, how was it? Talk to me.
Sir,
Mm-hmm.
so I wanted to ask how you got the 24
24? Where?
when you were trying to find the
Oh, the
factor.
factors of a polynomial? Okay, good question. I multiplied the coefficient of x squared by the constant. I don't know how it is that your other teachers taught you when you're in little school, but in a big school, that's how I teach it. I teach about prime factorizing. Some teachers will say you have to do it by inspection, but sometimes you still don't know where to go. And the time you inspect it, you just work the question. I multiply the coefficient of x squared is 2 by the constant 12. The coefficient of x squared is positive 2. The constant is positive 12. So now I multiply the coefficient of x squared by the constant, I'm going to get 24. Now I need two numbers. When multiplied together will give me 24. But when I add those two numbers, those two factors, I'm supposed to get the middle term, which is 11. So 2 into 24 goes 12 times, and I'm prime factorizing, so I'm only using prime numbers. So you'll never catch a 4 outside here, you never catch a 5 outside here. Sorry, you catch a 5 out here. You never catch a 4, you never catch a 6, you never catch a 8, you never catch a 9, or a 10. Only prime numbers that you'll catch outside here, right? And of course, you know that 1 is not a prime number. So the first prime number is 2. So 2 into 24 goes 12. 2 into 12 goes 6. 2 into 6 goes 3. I recognize now that 2 cannot be exactly, it's not exactly divisible by 3. So I have to move on to the next prime number. And the next prime number so happens to be 3. So 3 into 3 goes 1 time. So I end when I have a 1 under here. Then I manipulate these prime numbers. I need two numbers when multiplied together will give me 24, positive 24. But when added will give me a positive 11. All right. So what I'm trying to do is to manipulate. So the first thing I'm going to do is to say, you know what? Let me multiply 2 by 2, I get 4. And 4 times 2, I get 8. But hold on, sir, but 8 and 3, no 11. One. And 8 times 3, my 24. Sir, I found my factors today, 8 and 11. Let me just confess something to you. You said, I was going to little school. My teacher never taught it this way. Did not teach it this way. And sometimes when I was in little school, I used to love maths. I used to love maths. Maths was my life. But guess what? When they give some numbers like 180, 5x squared rate 88 plus 180, I couldn't do that. Because the little method that I had in my headspace to just multiply things quickly so I can see the answers quickly failed me. So I had to use my next best method. So you may give me a test with 10 of these questions. One very difficult one, and for sure I'm going to get 9 out of 10. Because a very difficult one, I'll be sitting down and trying to find the factors. I can't find the factors. But I guarantee you, when you prime factorize, the factors will always be there sitting in front of you. My teacher never taught me this. Years later, when I started teaching, I said, nope, I must find an easier way to teach this stuff to the students. And I found this easier way. Trust me, nothing beats this method. Nothing beats this method. Good to go. Thank you for being good students. I hope that answered your question. Thank you for being good students, even though some of you, I know, did not open the math book over the Christmas break. But I want you to hit the ball running. Here you go. I am pretty much finished with this topic. Next time you see me, all being well, we'll be having a conversation about a new topic. More than likely trigonometry, because I mean, I as I said before, I use my time, my Christmas time to do the preparation for the topic. So, more than likely to be treats. Have a good night. Be good and thanks for coming out.
You too, sir.
Okay, bye.
Post the recording.
Bye-bye.
Somebody say something about the recording?
Yes, sir. Going to post them.
As per usual.
Bye-bye, sir.
Bye-bye, Natalie. Sure. Bye-bye. Yeah, man. Be good. Bless up. Oh,
Bye,
sorry.
sir.
Yeah, man. Finger. Oh, goodness. Tanil,
Yes, sir.
I'm going to ask you to end the session for me, please. Here.
Okay, sir.
Thank you.